Hello students, hello, and a very warm welcome guys. I believe it's audible. You just quickly cross-check this thing. Yes. Hi Papi Reddy, hi. Join the quiz guys, join the quiz and I will begin the quiz very soon. So it's going to be a complete quiz on current electricity. We have this quiz today shortly after JEE mains analysis, because this is one of the most important topics, like one of the I would say the most heavyweight topics in your in your JEE mains. We have noticed past 10 years paper pattern, at least 3 questions are being asked every year. Hi Kavya, hi. Join the quiz guys, it's 894691. Quickly join the quiz and we'll get started with the quiz. So yes students, one of the most asked topics is going to be current electricity, and it is always you'll see that there are 3 questions at least in your JEE mains paper. So 2 shifts combine 6 questions in your paper, so you're going to see 6 current electricity questions, and trust me guys, this is one of the easiest thing. And throughout this quiz I'll be giving you the hints that you need to apply to solve the questions. And of course you need a pen and paper to solve it very quickly, but do get your pen and paper, share this video with your friends. It's going to be a very interesting quiz. Just type in 894691 on your like on your quiz this thing ID, and you'll be able to get started. And students, if you are not yet aware of the process, let me quickly take you through the process guys, quickly through the process. Up until then, 894 we already have 1 student, 2 student, and yeah, but still we'll wait for some time until more students join the quiz. Kavya, you can join the quiz. Hi Papi, I think this is Papi. But anyway, we'll begin the quiz by 7:40 and all. We can't wait more than 7:40. So good. I'll be giving you hints, students. Make use of that hints and try to understand the concept. And during the session, at least do one thing, like on your pen and paper, first of all write down the concept. Let's say it's related to Kirchhoff law, write it down. Like let's say first question was related to Kirchhoff law, write it down. Maybe it's a very simple question, you never know. Maybe the second question is related to, maybe let's say something like infinite resistance combination, etc. Write it down. That way you'll know whether at least your approach is going correct. We'll discuss the solution as well. And don't limit your challenges, but challenge your limits. It is very important that you keep challenging your limits each and every time, so that you become better and better. And in this quiz it is going to happen. And trust me guys, and students who don't know me, I'm Murlidharan Gopalakrishnan. I completed my MS in electrical engineering from one of the top ranking American university, and I'm also an IIT who completed BTech from IIT Guwahati. I filed 25 plus patent applications in India and abroad. And guys, today we are on current electricity and we are going to get into this quiz with an electrical engineer, and we already have 3 students. So yes, quickly join the quiz. It's going to be very interesting. It's 894691. Just join the quiz guys. It's no more time to think about the quiz, whether you'll be able to do it and etc. I'll give you the hint, and in fact the first question is going to be very simple. I kept the first question very simple for you, but careful. So that being said, students, if you don't know how to run this quiz, all you need to do is type in Unacademy on your Google Play Store and App Store, and the first search result is going to be Unacademy learning app. You will just click on to this. Very good Papi. Just click on to this Unacademy learning app, the most downloaded education app, and it's impacting near about 7 million lives a day. And guys, again, this quiz is a free of cost feature. Just click on to this link, click on the install button, log in, then click on the left hand top corner extension bar. There would be an extension bar over here, then choose plus, and then choose test tab. You would see typically 5 tabs: home, syllabus, browse, and updates. Click on this test tab and then click on the join quiz button. Once you click on to this test tab, once you click on the join quiz button, you will see something like this. What's your question, Papi? Code Nani, it's 894691. You need to type in your code over here, students, on the quiz ID section. Once you click onto this, this will pop up. This is what you need to do. So I'll quickly get to your question. So you're saying I completed up to the combination of resistors from my college. So that's hi Nani. You can see my profile. You can check out my profile. Join the quiz, guys. Join the quiz. The question is, sir, I completed up to combination of resistors from my college now. Can I take up this quiz? Yeah, you can take up this quiz. First question is going to be a basic question. Students, it does not matter. I'll keep giving you hints in each and every problem. So don't worry about it. Even questions can be from electrical instrumentation. If you haven't covered it, it's totally fine. Don't worry about it. Alright? So combination of resistors, Poppy, you can do a thing. If you think, okay, one more important thing, students. If you think you're not able to attend some of the questions in the quiz, of course it won't happen that you're not able to attend any question. In fact, it's based on the model problems like what is being asked in a JEE means a JEE Advanced. But if you think some of the questions, if you're not able to attend the quiz, start systematically attending current and electricity lectures on YouTube. So I've completed the entire portion of current and electricity on YouTube. You can check it out. Nani, are you getting onto the quiz, guys? 2 more minutes. We'll get started with the quiz. So quickly get onto the quiz. Quickly get onto the quiz, guys. And you can see my video on the laptop. So I'll keep giving you some hints over here, and based on the hints you can start solving the problems as well. So don't worry about it. So you can watch the video on another mobile device or laptop, etc. Okay. Good. So Nani, are you joining the quiz? Guys, do join the quiz quickly. The quiz code is going to be, just I write down the code again. That when we are switching over the screens, so it should be 894691. Just type in the code, guys. Type in the code quickly. So I think Nani, are you going to join the quiz? And students, do join the quiz. Even if you are watching this quiz session, try to attend it from just using a pen and paper, or somehow try to attend the thing. And 2 things that you need to do. First of all, write down the concepts that are involved in it. It can be multiple concepts sometimes. And the second thing that you're going to do is approach. First, do both things. If you get it correct, even if you don't get the answer within that 80 seconds, it's still fine. Then approach the solution and write down this. This is something that you have to do in this quiz kind of sessions. Alright. So quickly, 1 more minute, we'll begin the quiz. That's it. Like 7:41, as soon as 7:41 ticks over there, we'll begin the quiz. And take up these kind of challenges, students, and still fine. If you don't get the answer, don't worry about the answer all the time. It's not always about the answers, it's also about the approach. So we have one more quiz, student. All right, it's 7:41. Rest of the students, the code is available over here. It will be visible all the time. If you want to join in between, you can join the quiz. I'm going to start the quiz. And there we go, the quiz begins. There would be like 20-30 questions. So current through a wire depends on time. I is equal to 20 plus 40. The charge crossed through a cross section of the wire in 10 seconds. Students, careful. You are being misled somewhere. So what is given? Okay, do this thing first of all. This is the first thing that you need to do, and the code is 894, and I don't remember the code exactly. 894691. Okay, what is given? Given is I is 20 plus 40, and what did they ask you? At t is equal to 10, the instantaneous charge. Okay, they haven't said how much charge is passed in the total time. At time t is equal to 10, how much charge is passing through it. What is this? 20 plus 40. This is 40. Let me erase this part and put it on properly. This 20 plus 40. How would you do this? It is math based concept. Okay, what is the concept involved in this? I'm not going to say the concept all the time. You need to know the concept. The concept is going to be I is equal to dq by dt. Integrated on the other side. So q is equal to good. 40% of the students have got it correct. Really amazing. Okay, we have someone Rocky Bhai who has got it absolutely correct. We have Gopalakrishnan who has got it correct. Papi, so your XP points are this way. Alright, I think very limited time is available. So what I'll do is I'll try to just come up with the concepts rather than just trying to derive the solution. I don't think hi Aditya. Lag, what can be done? I'm not sure. Let me check out what. Don't think anything can be done about the lag. So I can maybe do a thing that is probably cut down presentation of that. Lag. Yes, what can be done about that? Are you still seeing some lag? I think there is a lot of lag. What can be done about the lag? I don't know. Probably I stay on the screen. Lag is less, maybe. Yeah, there is a lag. There's definitely a lag. The thing, let me close all the process. Done. I think now it is faster though. Yeah. Do you see lag still, guys? I think 3 seconds is left. Okay, I could have said what could have been done in the question. I don't think I can solve it parallelly, but anyway, I'll give you the hints in each and every question. And very good Rocky, very good Nagendar, very good Gopalakrishnan, very good Papi, everyone, really good. So yes, how do you go about this question? The maximum current in a galvanometer can be 10 milliamperes. Its resistance is given to you. To convert it into an ammeter of 1 amp. So what you are going to do to convert it? You are going to shunt it, right? You are going to shunt it. How will you shunt it? You will connect a resistance in parallel. Okay. So series goes. Okay, the answer is also as anyway. The answer should be among B and D. And among B and D, try to approximately work it out. What should be the answer? Because it's quite visible. Sometimes you need to move by the options, students. Okay, this is a way you can do in your JEE Mains as well, JEE Advanced as well. Series, you'll cut out method of elimination. Then you have two options. One is 0.1 ohms and the other one is 100 ohms. Guys, come on. This is very simple. Okay, 1 amp is how much current it should, the galvanometer should allow, or the shunted galvanometer should allow. 1 amp into X is equal to 10 milliampere into 10. So it should be 10 into 10 to the power minus 3 into 10. Right? So it should be 0.1. Good. Really good. Really good Rocky, really good Nagendra, really good Gopalakrishnan, really good Papi, really good Ambika, really good Manju, very good. Let's get into the next one. So this question could have been done just like that, but this thing, let me just have a look at this question. I'll quickly give you the hint. Two long coaxial unconducting cylinders of radius A and B are separated by a material of conductivity rho. Okay. And a constant potential difference V is maintained by them using a battery. If you connect it across a battery, a constant potential will be maintained across this coaxial cables or coaxial cylinders. Then the current per unit length of the cylinder flowing from one cylinder to another cylinder is. Okay, so they are coaxial conducting cylinders of radius A and B. Okay, and how they are separated? They are separated using some material of conductivity, and potential is maintained by a battery. So this would not be which kind, it would be, I believe, from one place to another place. Across the cross section it should be. So probably you can eliminate option You can eliminate two options, right? We have done a similar question earlier, right? You could have eliminated option B and D. Among A and C, you should have analyzed. Okay, let's move like like a JEE mains exam, etc. That would be really good, Rocky, really good, Nagendra. So your XP points are at, guys, simple. A battery of EMF E and internal resistance is connected across a resistor of resistance R. The resistance R can be adjusted to any greater value than or equal to 0. Okay, the graph is plotted between B and I. B on y-axis. Okay, I passing through the resistance and the potential difference. Select one or more of the correct options. Okay, can VI be a straight line? Think about it carefully. A battery of EMF E and it also has an internal resistance and it is connected across a resistor. So R can be adjusted to any value greater than or equal to 0. Okay, it's like a rheostat. Okay, and it can be 0 or anything more than that. Then the graph is plotted between I passing through the resistance. Okay, I means basically current passing through the resistance and the potential difference V across it. Okay, select the correct alternative. Okay, you could have found out the slope. From that slope you could have found out the relationship. Then you could have used E minus IR is equal to E means EMF minus IR is equal to your potential drop across that resistance. Right. In the current shown, in the circuit shown, EFGH are cells of EMF 2 volt, 1 volt, 3 volt, 2, 1, 3, 1. Okay, 2 volt, 1 volt, 3 volt. So, and the internal resistance are like 2 ohms, 1 ohm, 3 ohm, 1 ohm, corresponding to the, like, just in the ratio of the voltages. Then which of the following options is false? Okay, of course, the concept is going to be Kirchhoff law, right? You can't move without Kirchhoff law. Okay, guys. So F and E, they have like 2 and 1. Okay, then you move in this direction. Let me quickly analyze this question. Maybe there is a hint around this. Oh god, what happened? I'm really sorry, guys. Just a moment. The quiz is on. Okay, quiz is on. Still 20 seconds is left. Let's quickly analyze this question. So I do a Kirchhoff law. It should be F minus E, 2 minus 3, 2 minus 1 and of minus 1. All right, it was basically Kirchhoff law based question, guys. So you should be applying Kirchhoff loop law. Okay, and also junction law to understand few of the things. So always start with junction law and then get into loop law. Good, very good, very quick, very good, very good. Okay, match the following, guys. How do you do this? It's very simple. Trust me, it's really simple. So what is given to you, like 4 resistances, 2 resistances connected in parallel, again 2 resistances connected in parallel. Now they are asking you maximum current will flow through which thing, maximum current will flow through which, minimum current will flow through which thing, maximum current will flow through which thing, maximum power will be across which resistance, and maximum power will be generated across, minimum power will be generated across which resistance. Okay, now let's do a thing, let's think about it in a very different manner. So this is a connected node. All right, so some current I will be entering over here, it will get divided, total current is flowing is I. Okay, let's go by this method. Here also it will be I. Just notice this. Okay, if you are attending the quiz, attend the quiz. The concept is very simple. I will be flowing over here, I will be flowing over, I will be coming out. If I is going to flow over here, how is this I going to get divided? In the reverse ratio of the resistances. It's in parallel combination, right? So if it's going to be in the reverse ratio of resistances, go by the ratio of the resistances. For an example, in this case, right, that's going to be A should have been the answer. Anyway, so in that question, how would you move about that question? You will find, if you find out current itself, right? you almost came to know, take some current as I, don't do the entire thing, and like between those two resistances and between these two resistances, there was two resistances in parallel, two resistances in parallel, right? Current I would flow, it would get divided, and that current, how would it get divided? Depending upon the resistances. For an example, in one case it would be 2 plus 4, I divided by 2 plus 4, that is I divided by 6 into 2, I by 3. In the other case, it is going to be 2I by 3. 2I by 3 would be through 2 ohm resistance. Similarly, I believe there was 5 and 3, and I think that was 5 by 8, and the other one would be 3 by 8. Okay, highest is going to be 2I by 3, which is 66% of 5 by 8. 5 by 8, it's going to be anywhere around like 50, 100, 100, and I think that is going to be like 500. I think anyway, you can do it on a paper very easily. So 8, it should be 8 times 80%. That's a lot. Moment, yeah, 60%, less than I think 2 by 3. So similarly, you can calculate for power. Okay, using that just that I. Let me get into this question. It's a potentiometer based question. You guys know it. Okay. And as a total resistance of galvanometer has zero deflection, then the value of R is, I think it's about internal resistance. There are few equations that you can make use of, or else you can move by the method. Alright guys. Alright, let's solve this question then. There are 9 wires, each of resistance 5 ohms. Notice the 9 wires: AD or AB, DC, EF, 3 wires. AE 4th wire, AD 5th wire, DE 6th wire, BC 7th wire, CF 8th wire, and BF 9th wire. Okay, now they're asking you what is the resistance across which one? AB. Notice something very carefully. It's a very easy question. Try to intuit something very logical for your analysis. Just like how we used to do cube based questions, right? There were cube based questions. If you remember, there was a very simple method. Similarly, you can make use of that method, guys. Or you can use symmetry. Use symmetry. Else just use symmetry. Divide it this manner and find it out. Then say that this equivalent resistance is nothing but, that equivalent resistance that you're trying to find out. Okay. So you need to intuit in terms of distance between AB. Okay. So probably you can eliminate CF and DE. Okay. Alright. Go by symmetry. I think symmetry would have been the fastest way to do that question. And it's going to be perpendicular axis symmetry or parallel axis symmetry. It's going to be perpendicular axis symmetry. Symmetry, I don't think symmetry will work. With two equal negative charges minus q are fixed at a point 0, minus a, 0, a on y-axis, a positive q charge will, alright. This is little electrostatics. Anyway, I'll quickly explain you the concept. So there are two negative charges, minus q, that is being placed at, both are negative charges. One is placed at 0, a, and the other one is placed at minus 0, a. Now q is released from rest at 2, a. I'm not able to write it down, but anyway, let's think about it. So yes, and there are two negative charges at along y-axis, symmetrically placed along y-axis. So let's say there's a positive charge. This will be attracting it. This negative charge will be attracting it. Anyway, along its if this is going to push it this way, this is going to push it this way, or pull it this way. So this would be pulling it this way. Okay. So now it will move to the origin and remain in rest. I don't think so. A or D. Just a moment. Let me quickly have a question. It will execute a simple harmonic motion. It will move infinitely. It will not move infinitely, of course. And it will execute. Okay, D. Very good. Very good, Kaushal. Very good. So the answer should have been D. Anyway, it's not A, B, and C. I believe till C we analyzed. It should have been D. Good. Kaushik, attend the quiz. Really good, Rocky. Really good. Again a galvanometer based question, again a revision for a galvanometer. When a galvanometer is shunted with a 4 ohm resistance, the deflection is reduced to 1/5. Again you need to do 1/5 etc. If the galvanometer is further shunted with a 2 ohms resistor, it's further shunted. Okay, it's not like it has like that 4 ohm is removed, but it is like it is further shunted with a 2 ohm resistance wire. Then determine the galvanometer current in the galvanometer. Now if initially the galvanometer current in galvanometer, okay, it's not too much related to galvanometer, guys. It is basic parallel, series combination question. Think about it that way. Initially I0 was flowing through galvanometer. Okay, then what happened? You shunted it with a 4 ohm resistance. Now the deflection reduced to 1/5. Then that means 4 by 5 I0 is passing through that resistance, which is like 4 ohms. Now think about it. If you put a 2 ohms in parallel, what is going to happen? And I think we can quickly even do the analysis, but I don't think the time is very short. But anyway, so what was happening in this case? Why did you see the current to be lesser? Because it was further shunted by another 2 ohm resistance. Okay, really simple. Now let's look into this question. Okay, that question could have taken a little bit of time, I agree, but still if you got the concept, it's good enough. Parallel resistances concept, I0 by 5, 4 I0 by 5, literally you could have intuited the value of galvanometer. I think that was like 1 ohm. Then what should have been, I exactly don't remember. If that is R, you know what, how the current gets divided in the reverse ratio. So this should have been like 4 ohms. If that was 1 ohm, I exactly don't remember. I think that was like 1 ohm. Then this should have been 4 ohms. Then you further shunt it to 2 ohms, you can find out. Again divide the ratio. Okay, simple. So 2 and 4 in parallel, you can do that. 2 into 4 divided by 2 plus 4, that is going to be 6 divided by 6 divided, whatever it is, you can just do that, math. Now let's get into this question. I think this is like a 20 seconds question. Let's try and solve it in 20 seconds. In the given circuit, the current flowing through 20 ohm resistance is 0.3 amp, while ammeter reads 0.8 amp. What is the value of R1? Again, guys, the ratio of, I think you need to do the 1 by R1 plus is to 1 by R2, that is 1 by 20 is to 1 by 15 is equal to, you will get it as 0.3 etc etc. The current would be in that ratio, and the total current is going to be 0.8. so the remaining current is 0.5. 0.5, how it is getting divided, it is all given in the question. Okay, all right, let's do this question. Then the length of a potentiometer wire is I, it's L. A cell of EMF E is balanced at L by 3 from the positive end. Okay. If the length of the wire is increased by L by 2, at what distance will the same cell give the balance at? Okay. Now what happens in potentiometer? What is the concept? Potential gradient, isn't it? It's potential gradient, right? Now if it is, see, so let's assume that original primary battery does not have any internal resistance. Of course, it is never told that primary battery has any internal resistance. If it is giving at L by 3, after you add a length of L by 2, where it should be giving that, this point, I think it is quite easy, guys. Where it should be still be giving L dash by 3. Still it's going to be L dash by 3. What's your L dash? It is L plus L by 2, which is going to be 3L by 2. 3L by 2 divided by 3. It's going to be L by 2. Sorry. Okay, answer came out. Okay, fine. That's fine, I guess. No, I don't think it is L by 6. It will be, see, it's going to be L by 2. Okay, Kaushik. Why Kaushik L by 2? What is that in potentiometer? What is happening? A uniform potential gradient is being maintained, right? It is of length L initially. What was potential gradient? Let's assume the potential of your primary cell was something like, don't give it any 5 volts etc. Let's keep it as V by L, V naught by L. You added L by 2 length to it. So it's going to be V naught divided by 3L by 2. So it's going to be 2 V naught by 3L. Now this is the new potential gradient. But your primary, that secondary cell's battery's EMF is constant, which was found out to be V naught by 3. So where will you find out the V naught by 3? At L by 2. Right? Something you can do it this way, so your potential gradient now is like 2 V naught by 3L. Okay, 2 V naught by 3L. And now you need to find out into X is equal to V naught by 3. Okay, if you do that, what are you getting? You will get X is equal to L by 2. I hope you understood it, Kaushik. Okay, this should be clear, students. Alright, again, guess we are missing out the next question. A galvanometer of resistance 20 ohms gives a full scale deflection of 0.04 amp. I think this is a previous year questions, guys. This is a previous year question. It is desired to convert it into full. Then the only shunt available. Okay, good Rocky, good Nagendra, good Gopal, good Ambika, good Papiretti, good Manju. Really good, students, really good. But this was like a previous year question, so you can check out the previous year paper as well, to understand the solution. We'll anyway go through the solutions. You can let me know in the comment box. I mean, in the live chat, of course, later on we won't be discussing it. In the live chat, if you're not understanding some questions, we'll do the solution as well. Okay, I believe the first question was very easy. It's basically an integration based question. And the resistor in which maximum heat will be produced. Guys, in which resistance maximum heat will be produced? Think about it carefully. Again, the same concept that we discussed earlier. Join these three resistances, 3, 6, 2. Again, there, join that 2 resistances. Okay, do that thing. That is going to be simpler. Trust me. Alright. One thing you can do is you can go by potential, but in this case I would typically recommend going by current. Okay, because here again 3, here again 2, you need to find out how much is the equivalent resistance. But I guess 1 by 6 plus 1 by 3 isn't that easy? Yes, that is easy. That is a little bit easy. So that would be like that would be 2 ohms. Again 2 ohms, that is going to be 1 ohm. If this is 1 ohm, you can find out the equivalent of this. So this is going to be 5 into 4. So 1 volt is going to drop across, 1 ohm is the first one. The second one is going to be 5 into 4 divided by 9. So that is 20 by 9. So either you can go by that method as well, potential method as well, but current method could have been a little bit easier, In that case, how current is going to divide and quickly intuiting what is it. Still, I think potential method could have also worked. Okay, you can find out what is 20 by 9 is what we got, 20 by 9. And in the other case, we had 1 ohm, I guess. So that would be like 20 by 9 plus 1 ohm. What should be the drop of potential? It would be in the ratio of resistances in series. Then you get that, like this is V into V divided by something like 1 plus 20 by 9 into 1, and the other one will be V divided by 1 plus 20 by 9 into 20 by 9. Okay, ultimately this would be like 29 V by 29 into 20. The other one would be like V by just the remaining would be dropped across the other one. Okay, let's get into the next question then. A spherically symmetric charge distribution. Again, I think an electrostatic based question, but it's a very interesting question though. A spherically charged symmetric charge distribution is characterized by a charge density. So notice we discussed this point. We haven't yet got into this concept yet, but still we discussed this point. In your exams, don't expect your charge density to be constant. It will be varying. Okay. What should be the answer, guys? It should have been B. Right? But I think this wasn't like an integration based question. This was simpler than, your integration based. I believe you are getting 80 seconds for each question, right? All right. But you're not getting 80 seconds. Anyway. So length of a given cylinder is increased by 100%. Due to the consequent decrease in diameter, the change in the resistance of the wire will be. What is the concept over here? Write down the concept. I told you, write down the concept. Even in the early case, you could have done that. But now in this case, what is the concept? Volume should be constant. Okay. The volume should be constant if your length of the cylinder is increased by stretching it by 100%. So let's say your initial length was like x, now you made it to 2x. What would happen to the diameter? Calculated. It's a very simple question, guys. Okay, think let's do it, but I don't think so. It should be like L into R square should be constant. Hence, if this was like x, and on the other side, if you have 2x, and then you can substitute it, this will be R by root 2. The new diameter will be R by root 2. So your resistance is rho into L by A, which is rho into 2x divided by A. Area is again increasing by twice. Okay, anyway, A into L. A into L is the simplest way to do it, right? So your 400%, so 300% would be the increase in your resistance. Okay, it's not 400%. 400% is the total resistance from the original one. So 300% has increased. Wasn't it simple? So yes, one more thing, students. Yeah, I too often do that. It's pi r square into L. As soon as you see a geometry, you get attracted to it. Simply do it as A into L. Area into length should be constant. That could have been the simplest way. Because ultimately you have to substitute it in rho into L by A. There, if you just substitute rho into L dash by A, substitute the new value of area, it's going to be A dash. It's going to be A by 2, and on the length you would have 2L. It couldn't have been simpler. Rather than going by R square extra steps, wasting the time. Don't do things like that. Even though while speaking I'm doing, while writing down, I'll definitely move by A into L as soon as I see rho into L by A. The same thing should be something that you should be doing. Alright, so let's get into the next question. Then two sources of equal EMF are connected to an external resistance. Connected to an external resistance are the internal resistance of the two sources. Alright, the internal resistance sources are R1 and R2, and one of the resistance internal resistance is greater if the potential difference across the source having internal resistance R2 is 0. One of the things is whether they are probably connected in series. Okay, and it is being said that internal resistance, I think picture could have been a little bit clearer, but anyway, I think they are in series and they are connected in an opposite way. That is when 0 is possible, right? In parallel, 0 is not possible. In parallel is 0 possible. Parallel also 0 is possible. Parallel 0 is not possible. Sorry. In parallel 0 is not possible. It should have been in series and it should have been opposite polarity. So that way you could have worked around this question. Try to work out the combination, try to note down the concepts. For an example, in this case, it could have been as simple as, connecting two batteries, and it should be in opposite terminal, it cannot be in parallel. And what else? Because if it is in series across both, then across both the terminals, it should be 0, right? If it's 0 across one terminal. And what else? Yeah, that is it. And that should have been EMF1 minus EMF2. Plus IR into R1 plus R2 is equal to 0. That way you could have intuited the answer. Okay, the current across R2 is 0. Okay. Anyway, let's get into the next question. The circuit shown, the steady voltage drop across the capacitor is how much? What is the steady voltage drop? Simple. It's very simple, guys. Okay, this is not a question of capacitance, it's a question of current and electricity. It should have been the voltage drop across R2, right? It should be B into R2 divided by R1 plus R2. Okay, answer should be C. Or D, that was R2. So anyway, in that case, it should have been the potential drop across R2. Alright, this is a lengthy question. So in the circuit shown in the figure, A and B are two cells. They are connected in the matching polarity fashion, and the resistance RA and they have internal resistance RA and RB, and L is an ideal inductor, C is an ideal capacitor, and the key is closed. When the current in the circuit becomes steady, what should be the value of R so that the potential difference across the terminals of cell A is 0? so that the potential difference across cell A becomes 0. Okay. What should be the value of R such that potential difference across cell A becomes 0? Anyway, one thing you identified already, I believe. So what is it? It's a Wheatstone bridge. Simply you would say, all right, there's a Wheatstone bridge, so no issues. And capacitor will act like an open circuit at a steady state. Is that what they are talking about? Yes, they are talking about steady state. And through inductor it will be passing like as if it's going to pass through a short. So that is not at all a problem. And good, 67% of you have got it anyway, correct. Leave discussion around this problem is not necessary. Let's get into the next question. All right, this is something that we have been often doing. This is a starter topic. Two rods are joined end to end as shown in the figure. Both have same cross-sectional area. Each is 1 meter long. One of them is rod of copper with resistivity something something, and the other is an iron with resistivity something something. How much voltage is required to produce a current of 1 ampere in the rods? The connected in series, guys, you need to do the calculation. It's rho into L by A. Just do the rho into L by A. I believe rho is given to you 1.7 into 10 to the power minus 6. For other one 10 to the power minus 5. So just do that. It's quite simple, I believe. And what could be done? I don't think any shortcut exists. 1 meter. So that is something. And take care of the centimeter square conversion. So it's going to be 2 meters. You're having resistivity is given in ohm per centimeter, so notice that thing as well. Okay, convert that into centimeter. That could have been the easiest way. So just convert your meter into centimeter. Okay, so it should be 1.7 into 10 to the power minus 6 into 100 divided by 0.01. That is going to be 10 to the power minus 2. Just cancel it out and you'll get the answer. Both are in series. Just add them and divide it. That's it. Find out the value of R from rho is equal to L divided by A. For both of them, add the resistances, divide by the voltage, that is the current. Okay, it's a simple question, but you need to do the math on your paper. Okay. Alright. Good, Rocky. Good, Nagendra. Good, everyone. Really good. Alright. And again, we have this question. Two sources of equal EMF are connected to an external resistance R. The internal resistance of the sources are R1 and R2, and of course R1 is greater than R2. The potential difference across the source having internal resistance R2 is 0. Okay, probably across the source having internal resistance R2 is 0. So they are connected in the opposite fashion. So let's say plus is connected to plus, but parallelly. Okay, plus is connected to plus parallelly, that is when this is possible. Okay, such that the current is flowing and this creates a potential that is in the opposite direction. So first of all, do that. And from that you will understand. And where is the resistance R connected? R should be connected. R should be connected in series to them. Okay. I believe there are two possibilities, but typically answer would come out for only one possibility. Okay, so you can take R is equal to, what should be the answer? Answer should be in some R2 minus R1 F 0 into R2 is equal to R1. Like that E minus IR2 is equal to 0 is what is given to you. So you can say, alright, let's get into the next question then. So 12 resistances, each of 10 ohms, are connected in the circuit as shown. The net resistance between point A and H would be. Okay. So there are 12 resistances between A and H. You need to find out the equivalent resistance. So there are probably somewhere, I believe there are like, Wheatstone bridges. Or from Symmetry as well, you can say there are like, Wheatstone bridges. So just try to analyze those Wheatstone bridges and okay, there isn't any Wheatstone bridge. Okay, go by Symmetry. Symmetry is the easiest way to solve this problem. Let's do a thing. Let's quickly analyze this question. So they're asking us between A and B or A and H. A and H. Okay, outermost point. Okay, outermost point A and H. So one resistance over here, one resistance over here. Let's say this and this are symmetrical points. I can go by folding symmetry. If fold it, what is going to happen? This is going to be like a very simple problem in which you have R and R. Be that quick. Anyway, go by folding symmetry. That is the easiest way. All right, let's get into the next problem then. All right, I think this is an easy one, guys. Don't get terrified by the number of resistances that you see over here. Let me give you a quick hint. Notice there are 4 resistances in parallel series, in parallel, right? That means what I'm trying to state is over here this 16 are in parallel, so this would be 4 ohms, this would be 4 ohms, this would be 4 ohms, and I think the resistance is between A and B is 12 ohms. And then what is this? This is another 4 ohms, 12 ohms and 4 ohms in parallel again. So it should be 12 4. We have done a lot of time, so that should be like 3 plus 4 by 12. So the answer is quite simple. I think this was like a cakewalk for many of you. But yeah, whenever node like this is given, just join them and understand the rest are in parallel. So this is an easy one. Don't worry about it. What should this be? This should be 12 and 4 in parallel. What is that? What I said? It should be 3 ohms, guys. All right. The 4 ohms or 3 ohms? 16, 4 ohms. Other side we have 12. 1 by 12 plus 1 by 4 is 4 by 12. It should be 3 ohms. Anyway, a piece of copper and other of germanium are cooled from the room temperature to 80 Kelvin. Okay, what is germanium, guys? What is this question related to? What is copper? What is germanium? Think about it carefully. Remember those graphs that we discussed? If you haven't attended electricity thing, let me tell you something very interesting. Copper is a metal. It's a conductor. Germanium is a semiconductor. What happens in semiconductor when you start heating them? More carriers. Hi Satvik. Hi. And it's cooled. It's not heated, it's cooled. What happens typically? Conductivity of semiconductor goes down. So both of them does not reduce, both of them does not increase. You understood that? Resistance of the copper will increase or decrease? It will increase, while that of germanium will decrease because carriers are freezed at 80 Kelvin. Now they will behave like an insulator. Okay. Yeah, hi Satvik, hi. Good Kaushal. Right. Don't worry. So the answer should have been the germanium. When you cool it down, its carriers will freeze, and ultimately, this will decrease. Its conductivity will decrease. All right. Let's get into the next one. Then match the following in column 1 with the results in column 2. Now this is a question which I need to also have a look at from my mobile. So let's do this question then. So it's a conceptual based one, guys. So quickly, this is doable in 58 seconds. Okay. A variable resistor is connected across a non-ideal cell. Non-ideal cell means it has internal resistance. As the variable resistor is continuously increased from 0 to a very large value, the electric power consumed by the variable resistor, does it first increase or decrease, and then what happens? So you have a variable resistor, you're taking it from 0 to a very large value, just keep it 0 initially. Okay, actually no power is going to flow, but take it as a very small value. All the power will be across that small resistance. It will initially increase and then it will decrease. So we can say A should be just P. And I think there are only two options. So you'll quickly go through rest of the options, which is apart from A is corresponding to P. Okay. Alright guys, no issues. That was little lengthy, but I believe next two questions are going to be super easy, and I'll also give you a very interesting hint around those questions. Okay. Alright, then this is a good question. What is this? What is happening? The relationship between current in a conductor and the time is shown. How is it varying? Is it y is equal to some one thing you can do in such graphs is what, before even walking around them, write down the slope over here, write down the slope over using these 2 points. Okay, y is equal to mx plus c. That means I is equal to some m into c, that is t in this case. What would be it? It would be some minus I naught by t naught. Then you'll start integrating it to find out charge. Okay, I dq by dt. Okay, so dq by dt is equal to I naught minus I naught by y is equal to mx plus c. Minus I naught by t naught into t. Once you integrate it, it has to vary from 0 to sometime t naught. Okay, total charge through the conductor. Expression of current in terms of time. This is wrong. B is wrong. Okay, there are many questions around this. What about charge? Let's see if charge is working out fine. Charge is fine. Charge is fine, isn't it? Half into base into area. Just a moment. Integrated this area. I think charge should be fine though. Alright. Okay, again we have that matrix based question. Let's try to solve this time quickly. Already we did option number A. When a variable resistance is connected across a non-ideal cell, as a variable resistance is continuously increased from 0 to a very large value, first it will increase for some time and then it will decrease. Okay, and if you remember that power transfer graph, okay, maximum power transfer graph, that is really that simple. And okay, the electric power. A circular ring lies in a space having uniform and constant magnetic field which is parallel to the plane of the ring, keeping the center of the ring fixed. Ring is rotated by 180 degrees. A circular ring lies in the space having a uniform and constant magnetic field which is parallel to the plane of the ring, keeping the ring center of the ring fixed. The ring is rotated by 180 degrees. Okay, and about one of its diameter. Okay, and which is perpendicular to the magnetic field with a constant angular speed. For the duration of the ring rotates, the magnitude of the induced EMF in the ring. So it's d phi by dt is equal to EMF. Alright. I think there was like increases, decreases, etc. So think about change in the flux, magnetic flux. Go by Lenz's law for the second, but anyway, that question was a little lengthy. It's okay, guys. Okay, we have done this question earlier, if you remember, but there is a catch. Unlike the questions that we used to do earlier, there is a catch. One is, what you can do? You can remove this node. Once you remove this node, you can tell me whether this should be x or x by 2. It should be x by 2. So you will say this entire thing is x by 2, total equivalent of infinite divided by 2, right? If this is x by 2, you need to calculate the equivalent, guys. You need to do the calculation. I too don't remember the answer, but you need to do the entire calculation. Okay, this 2 will be in series, so you'll give them some value. If you assume each side to be r and r, you will do the value, you will calculate it. Ultimately, you will get it in terms of r, which you need to substitute in terms of a and rho. Okay, but the simple hint is try this question later on. It's a very interesting question. This is not x, but this is x by 2, right? Once you're going to substitute for how you do it for infinite resistance series, you need to do it that way. Good, very good, amazing, Nagendra. Good Rocky, good Gopal, good Ambika, good. Really amazing, nice, really beautiful. Okay, we may have a look at few questions. Don't worry about it. We'll have a look at the solutions for few of the questions. Whichever question you ask will be first. Else I'll just go to the tricky ones. Okay. So the resistance of the copper decreases and germanium increases. We did this. Okay. So it's D, right? Anyway, it is cooled. So do notice few things in your exam very carefully. It can be a very easy question, but don't miss it out in your exam. I think this is a previous year question. The piece of copper, another of germanium are cooled from room temperature to 77 Kelvin. Should I repeat this? Obviously, a piece of copper and another of germanium are cooled from room temperature to 77 Kelvin. The resistance of, so whenever copper is a conductor, germanium is a semiconductor. When you cool down germanium, the carrier freezes, its conductivity decreases and its resistance increases. So germanium's resistivity should increase. And for copper, what happens when you're trying to cool down? The collision decreases. Hence, all these thermal agitations have come down and hence its resistance will decrease. Its resistance will decrease. Its resistance will, for germanium, the resistance will increase. For copper, since they don't have any collision, the resistance will increase. Okay. So it decrease. I mean, copper's resistance will decrease, germanium will increase. It should have been D. No, it's not A, it's D. Good Nagendra, really good, amazing XP point 783, Rocky good, 733, good Gopalakrishnan, really good, good Ambika, good Papi, very good guys, very good. Okay, let me come to the germanium question. Since it's a conceptual question, we'll get started with that. So I think one of the students, Kaushik, has a query around it. You can once have a look at the current electricity lecture. So what happens when you heat a semiconductor? The resistance decreases, its conductivity increases. But do notice the question what was asked. If you remember, let me go to the question. Okay, if I'm going to that question, it was the last question as I remember. So what is happening? I'll take you through each and every solution, guys. Don't worry about it. So copper, what is happening? So copper is a conductor. When you're heating it, its resistance increases. When you're cooling it down, here you're cooling it down. Again, I'm repeating it. Notice it in your paper. It often happens. Students know the concept, but they make a mistake. When you're cooling it down, its resistance decreases. Whereas germanium, when you're taking it to 77 Kelvin, 80 Kelvin, what happens? Carrier starts freezing out. All the holes and electron pairs starts freezing out. That means there is no movement for the like electrons or whatever, charges, like conducting charges in those semiconductors. Hence, what would happen? Its resistance will increase. Okay, on decreasing. First is, guys, Nagendra, amazing Nagendra, 783 points. That's pretty good. Second is Rocky. Third is Gopalakrishnan. Fourth is Ambika. Fifth is Papi. And sixth would be Manju. But anyway, you have attempted it. That's the most important part. And we'll go through some of the solutions as usual. And guys, first question was about integration. Okay, it was just about simple integration. And I think it was for the total time, not for one time. So the current through a wire on time depends on this much. Then the current passed through the wire in 10 seconds. Okay, it was not like a 10 second, but total 10 seconds. Okay, so you would integrate it. I think I've told you the wrong thing. It was a 10 second, not a 10 second, but for 10 seconds. All right. And I think second question is very easy. You don't need it. And let me see. I think let's go through the fourth question then. Okay, I think second question I'll quickly tell you what needs to be done, and I'll also show you the solution. So there is in the given figure there's an ammeter A1, A2 and A3. Okay, A1, A2 and A3, and the ammeters are identical, while that of one of the ammeter A1 reads 10 milliampere. Okay, A1 reads 10 milliampere, and while that of voltmeter is also there. Okay, there is an A1, A2, and there is a voltmeter. Okay, and the ammeters are identical. The internal resistance of the battery is negligible. Consider all the ammeters and voltmeters as non-ideal. Hi Prashant, hi. So if they are non-ideal, they would have some internal resistance as well. Okay, but any hint is given across the resistance? Nothing. So what was asked in the question? I exactly don't remember. So the ammeters are identical. Then So I think bunch of options were given, and finally you had to arrive at some. Okay, let's do a thing. Let's go through the question again. So voltmeter reads 3 volt, and ammeter which is connected A to A1 reads like how much? A1 reads what is the current flowing through A1. A1's current that is flowing through it should be the current that is going to flow through this part of the circuit, not this part of the circuit. Okay, so what you have done is you have basically equated V4 minus V1 divided by 100 is equal to V1 minus 1 divided by R4, and so on. You have got for each, like for ammeter RA, and you have added all the currents and just applied your simple node law and got the resistances, and post that again you did it and you got the voltage resistances, and again I think it's going to be like current this time, and you've done the question. All right, so I think this one was simple. I told you what should be done, and all right. So yes, if you remember, one of the things is this is totally it'll take a little bit of time to solve. So in such cases, do remember when I'm talking about coaxial cable and the current flowing through coaxial cable, even in your exam, there were like 4 options. In only 2 of them log was there. Okay, you have even integrated it and quickly done it, but what I'm saying is one of the simplest way to do it is assume some dx length, and what is happening, area is varying all the time. Okay, so you'll say rho into L by A. So dx is the length through which it has traveled. What is the area? Area is going to be 2 pi r. Okay, in this case it's going to be 2 pi x, and then you integrated it and you will get it as something like it is like 1 by sigma, which is nothing but conductivity, but instead you will get it as, if you do it by rho by A, you will get it as rho by 2 pi into log of B by A. Okay, in such cases log should be present, and of course a bigger radius will come on the outer side. All right, so next, okay, this question was also very interesting. So the battery of EMF E and internal resistance R is connected, and a graph is shown. Select the correct alternative. We don't have the alternative, so we'll do a thing. What was the alternatives given over there? I don't remember exactly the alternatives, but from the solution you can find out the alternatives. Okay, I think from this VI graph we can find out maximum current. Okay, from the maximum current we can get the value of, I think EMF was asked. EMF was asked, I guess. EMF of the battery was asked, wasn't it? So simply do E minus IR is equal to maximum current would flow through it only when internal resistance is neither given to us. Alright, I think we don't have the options, so we'll pick up some questions where we have an option over here. You know how to do this question. I told you, either move by potential or move by current. So let's do a thing. Take up some interesting question. I think everything is fine, guys. Let's do it. Okay, this one, how do you go about it? In this, total current is 0.8. Okay, you take I1 plus I2 plus I3 is going to be 0.8, and then you will say R1 is to R2 is to R1. Else, one more thing you could have done in this case, I think, very simply what we could have done is, not going through all the hassle of solving each and everything, you could have simply taken the parallel combination resistance. Okay, from that we could have simply guessed R1. I don't know if the solution is also in that way. Yeah. Okay, let me tell you an easier way of doing this question. So what could have been done is, it could have been a very simple question given that we have put in some thought. So 2015 take a parallel combination. The question number 12 I'm talking about. Okay, if you take a parallel combination, it's going to be 1 by 20 plus 1 by 15. So it should be like 60, 3 plus 4, 60 by 7, something like that, I guess. Is that correct? I don't know. 4, 3, yeah, 7. 60 by 7. Okay, 60 by 7 divided by R1 is equal to 0.5 by 0.3. 5 by 3. Okay, that could have been even the smarter way of doing it. I don't know why didn't I think about it back then. So yeah, that could have been a smarter way of doing it. We need not have done the entire thing, you know, like R1, R2, etc. So yeah, that is only is being done. I think 20 ohms is point. Okay, 0.3 is given to you. Okay, that is what is being done. Okay, okay, to 20 ohms is given, not through R1 is given, but through 20 ohms is given. All right, guys. I think this was easy. This was fine. This was easy. Yeah, if you remember this thing, this question, whatever the potential drop across R2 is, that is the potential drop across the capacitor. So it would be V into R2 divided by R1 plus R2. Right. And what else do we have here? It's calculation based question. Calculate the resistance of each individual piece. They are in series combination. You'll add them up. If the solution is not still visible, just do it on your own. You should get the answer. You can rewind it to have a look at the answer. Okay. Now in this case, I think symmetry was applied. Yeah, you can remove the resistance C and DF as I told, and still apply even symmetry even after that, and the question could be quick. All right. Yeah, this was a simple one. I think you may want to go through this, but I believe the solution would not be visible. Okay, all right, the solution is visible. Okay. So, but anyway, but you can go through this question. This one I told you what should have been done. You should have taken it as R by. The entire thing is x by 2. Okay. Hi Satvik. Hi. All right, guys. So I believe today's quiz is complete. If you have any doubts, you can post it out on the comment box, and I'll get back to you quickly. And that being said, students, do not forget to like this video, share this video. We'll have more amazing quizzes like this. And students, that being said, do not forget to enroll to the Optics Basics to Advanced coursework, especially if you're on subscription platform. Guys, do quickly get onto this coursework. We have started solving very interesting problems, and we are on very interesting concepts. You know what? It's a very easy class. Given that you have come to this, it's a very easy topic. Optics is a very easy topic, given that you come to class very regularly. And anyway, in this course, everything is going from basics until your advanced level. So anything that is required for JEE Mains is covered. Everything that is required for your JEE Advanced is covered. And everything even around your basics are covered. So don't miss out this coursework. It's going to be a comprehensive coursework. It's an ongoing course. It's not going to be, but it's an ongoing course on optics. It includes both wave optics and ray optics. So be sure to attend this coursework if you're already on an Unacademy subscription, and if you're planning to purchase an Unacademy subscription, this is the time to get onto this coursework, since we are yet to get into many of the important things around optics, and we have just to an extent covered, you know, like reflection, and we are about to cover reflection this week. But that being said, you know what, that is only one part of the optics. You have the rest of the part of the optics left over, and by the way, you can, you know, cover the rest this reflection part through recorded videos as well. And be sure to attend this coursework. And that being said, do not forget to share this video, do not forget to like this video, do not forget to click on that bell notification and subscribe button, and keep working in a smart way. And even in the quizzes, try to write down the concepts that are involved, and probably even if you don't get solution, that is totally fine, but try to get the solution as such within the given time. But anyway, that being said, students, work hard and smart to achieve your success. Not just working hard wouldn't help you, but also work smart. Do check out all the strategy sessions. Everything is available on JEE English for free of cost. So do not forget to share this video, do not forget to like this video, and do not forget to, you know, get onto a Telegram channel as well. And this is that one place where you will get all the updates on JEE English, that is like YouTube channel that we have. And not only that, any lectures that our team, JEE English team, conducts on Unacademy Learning App. So do get onto a Telegram channel. If you don't have a Telegram app, just download it. from your Google Play Store and App Store, and click onto this link available in the description box below, or just type in JEE_English to find us on Telegram. And that being said, students, you know what, if you haven't yet started covering units, dimensions and measurements, this is the time to get started, because it's very easy, it's less time taking, especially 2022 aspects. As you know, this is your first chapter. You'll get a complete material on units, dimensions and measurements on Unacademy Learning app with all the kind of model problems that you want for your JEE Mains and JEE Advanced preparation. And moreover, guys, you know what, this is just, you know, like one part of it. We have many things going on Unacademy Learning app. You may want to check out, and units, dimensions and measurements is the easiest among all the topic, and definitely one question every year in your JEE Mains. Typically and generally you will get at least one question, and almost only one question generally, but it's the easiest part, less time taking. And what else do you need? And also you get one question every day in your JEE Mains and JEE Advanced. So combined there would be, you know, like 2 to 3 questions that you'll see throughout the year. So at least 3 questions throughout the year during your JEE Mains and JEE Advanced session, and it was all covered in 4 back-to-back session plus a 5th model problem session. So hardly few hours for, you know, one of the questions that you want in your JEE Mains and JEE Advanced. So be sure to attend this session. And not only that, guys, if you have been you know, like not downloading Unacademy Learning app, this is the time to download Unacademy Learning app, because there are many such free of cost sessions going on, and even to attend this quiz you need to download Unacademy Learning app. So just type in Unacademy in your Google Play Store and App Store, and the first search result is going to be Unacademy Learning app, the most downloaded learning app. And then once you click on this Unacademy Learning app, click on this install button. That's all you need to do. And guys, let me tell you something amazing. If you're looking for a champions tool for your JEE Mains and JEE Advanced preparation, the best thing that you can have for your JEE Mains and JEE Advanced preparation, that is going to be Unacademy subscription. Why? We have the best educators across the nation on one platform, that is going to be Unacademy subscription. You can attend daily interactive classes with the best educators across the nation, and not only that, you can also get your doubts cleared on time from the best educators across the nation. And more importantly, students, think about it this way, like, you know what, Unacademy subscription is, it's just not about lectures, but it's about a structured program where you'll be undergoing daily interactive lectures along with dedicated doubt clearing session and quizzes, test series, national level test series, everything in one place. That is going to be your Unacademy subscription, of course. And guys, not only that, you know what, yes, of course, all these things, yes, but you can also get the feel of JEE Mains and JEE Advanced. So yes, all you need to do is click on the left hand top corner extension bar, choose plus, and then you will choose IIT JEE as your goal. With that, you will be ready for both JEE Mains and JEE Advanced, and then you will click on the get subscription button. And guys, what is it? It's one subscription, unlimited access. So do remember to enroll to like as many programs as you want, still plan accordingly. And we have dedicated programs for JEE Mains and JEE Advanced, and also the best, not only the best educators across the nation, but also legends like DC Pandey sir on this one flat. And guys, the price is also quite reasonable for this kind of value that you get. It's going to cost you less than 70 rupees a day, and that is like, you know, 2,100 per month, less than 70 rupees a day. And guys, typically 24-month program is meant for 9th class students, 10th class students and 11th class students. And students, yes, and you can apply Murlidharan coupon to get to this price point and the best discount on your subscription purchase. So your best discount would be you know, availed by getting Murlidharan coupon. So do not forget to apply Murlidharan coupon and get the best discount on your subscription purchase. And not only that, students, you can use a pay in parts option, which is our in-house option, which takes away the burden of paying all the fee at once. So this is the awesome thing about Unacademy. We give you with, you know, options that lets you not go through the hassle of paying all the fee at once. And not only that, we also have no cost EMI option, and you can use this option as well to avail, you know, like your subscription in multiple parts. It's going to be a totally no cost EMI. You don't have to, you know, bear any interest. And yes, we have our in-house feature. If you're not comfortable with no cost EMI, you can check out our pay in parts option, in which you can split your subscription into multiple parts. We also have other traditional payment modes like debit card, credit card, UPI, etc. in one place, and with the best educators across the nation. Yes, that is the awesome thing about Unacademy. And guys, let me tell you something. If you are looking for, if you're a dropper or if you're a long term, and if you're looking for a suitable program for JEE Mains and JEE Advanced preparation, that is going to be a 12-month package. It's a complete package, guys. If you're long-term dropper, don't hesitate. This is the time to get started. And even if you're 12th class and if you're planning to prepare only for next few months, it's going to be a 12-month subscription. And guys, you know what? The price is also quite reasonable. Again, it's less than 2,900, only 2,888 only. If you check out the price, it's quite reasonable. And you know what, you can apply Murli Live coupon to get the best discount on your subscription purchase. So by applying Murli Live coupon, you'll get the best discount. And what more do we have on this Unacademy subscription platform? Test educators, daily interactive classes, not only best technology but also dedicated programs for your JEE Mains and JEE Advanced preparation. So let's say if you're lagging in one topic and if you want to get the topic done really well, it's going to be an Unacademy subscription. And we have 6,000 plus materials for your JEE Mains and JEE Advanced preparation. And even if you're a dropper, we have dedicated programs for that, capsule series, etc. in one place. And guys, do remember, we also have right now going on like 1,000 plus live programs just for JEE students, JEE aspirants. This is the time to get started. It's never late, so get started right now. And even if you're in a 2022 aspirant, be quick on your things and do not hesitate to give the test series, do not hesitate to give the quizzes. See you in the next class. Take care, stay